over. Let's try a few more with chain rule. All right, so on B on the back side, dy dx is, find dy dx given that y is 1 over 2x to the 5th minus 7 cubed. There's actually two ways to do this one, but I'm going to just, it's a quotient, so I'm going to do quotient rule. So I first look at it, and I'm going to be doing multiple rules. I'm overall doing the quotient rule. While doing the quotient rule, I'll need to do the chain rule. So y prime, in other words, dy dx, the derivative of y with respect to x. Let me write that. It's the same as y prime, but this one's more descriptive. It tells you what variable we're doing the derivative in respect to. So I'm in quotient rule. G, my load, write that down, 2x to the 5th minus 7 cubed, times d high, gf prime, load d high, derivative of 1 is 0, minus the high is 1, d low, so I'm doing the derivative of the low. This is the g prime. So right here, while doing this, I'm in the quotient rule, but now to do the derivative of that, I need the chain rule. So right here in this section, doing the derivative of that, that's where I'm doing multiple rules at once. This is where I'll do the chain rule. So this one is similar to the last one we just did, right? The u to the 6th one. Let me do the method I described before, where it's f prime of g times g prime. So looking at this, the outside function is something cubed, x cubed, u cubed, if you want to say. So doing the derivative of that, it is 3 times my u times something squared. Notice I don't put the answer. I mean, if you already know what it's going to be, as soon as you get used to this, you'll know it's going to be. So I just did f prime, I did that part in red. I write the g, that was the inside part here, 2x to the 5th minus 7. And now I'll do times g prime. So that's the derivative of the inside. So what you notice, guys, there's this continual, like this part. Sometimes in the past, I've drawn this arrow. Like, you're doing the derivative. Sometimes I put this, like, d dx of that goes right. Like, we're doing the derivative of just that inside part. So what is it, 10x to the 4th? And 0. So it's 10x to the 4th. So that was the chain rule. Low d high minus high d low, we just did. And finally, over low squared. What was that? Oh, it's cubed. I'll go ahead and write it like this. I'm going to take one more step here just to combine some terms. If you already see, that's going to be the 6th power. You could write that as well. Let me do one simplification step. That's all I'm going to need. This is 0. The numerator, -1 times 3. It's -3. And then I can't multiply, right? I can't distribute that in because there's the squared there. So I got -3, but I can multiply that with the 10x to the 4th. So it's going to be -30x to the 4th. 1 times 3 times 10. And then I'm just keeping the 2x to the 5th minus 7 squared over the 2x to the 5th minus 7, and I'm going to write it to the 6th power. The cube squared is to the 6th power. I guess I need one more step. I thought that was going to be it. Lots of times we'd be done there. We kind of combine the numerator. But the one more step I'm going to do, there's no binomial in the numerator. There's no plus or minus. So these are all multiplied. I can cancel 2 of these. 2x to the 5th minus 7 is in the numerator and denominator. So, final answer right here, -30x to the 4th, that's all that's left in the numerator, 2x to the 5th minus 7 to the 4th in the denominator. So, a, let's see, combination of quotient rule to start. While doing that, we do the chain rule. And the chain rule uses the power rule. So you just got to go in order, see the overall rule you're using, and along the way you might need chain rule or some other rules. So I got two more. Anything else on B to clarify? No? Let's do two more. On C, find G prime given G, the function. So G is tangent. So here we go. One from recently, a trig derivative. Now normally, tangent of x, right? That would be no chain rule needed. Tangent of, or in this case, t. Tangent of x, that would be the parent function. This is tangent of 5 minus sine t. So overall, the outside function, hopefully you can look at this, identify it, is tangent. So let me write down the chain rule again. It's f prime of g times g prime. So my outside function, my f, is tangent. I'll go ahead and write like this and this one. My inside one there is g. Please remember to note the difference here. If it was tangent x times 5 minus sine 2x, that would be product rule. This is not tangent of x, though. It's not two functions. This is tangent. This is just one function. Yeah, I'm just remembering now. These are in the past. Sometimes things want a product rule. It's not. So I'm writing f and g, but that's for the chain rule over there. It is one function, just tangent. So let's go ahead and do it. So I'm doing f prime. So I'm doing the derivative of my outside function, tangent. That's secant squared. Now, notice I'm not writing secant squared x because it wasn't tangent x. Right? It wasn't tangent. If it was tangent x, I'd write secant squared of x. But it was not. I just did this part right here, f prime. I also did the parentheses. So I did f prime of, and I write in g. So I keep my g right here. 5 minus sine 2t. Okay, and then let's I'll go green. Then I'm doing g prime. So again, this is where I sometimes write this, like I'm doing d dt. I'm doing the derivative and putting it there. Derivative of the inside. Do the derivative of the inside and then multiply by that. So g prime, the derivative of this, derivative of 5 is 0. Derivative of negative sine 2t. Now, look at this. Is sine 2t, is that a parent function? No. It would be sine of x, would be good. So what rule do I need to apply to do sine of 2t? No. No. Chain rule. Again. Because it's not, it is not sine of x. It's sine of 2x. Anything that was not a parent function. So this is an example of chain rule twice. And this is why sometimes it's helpful for me to write it like this. Like I'm just continually doing the derivative of the inside in the next term. So I'm at, okay, I did f prime, derivative of tangent, secant squared of g, 5 minus sine 2t. I'm doing the g prime over there. So I'm doing the derivative of the inside here. 5 was 0. I bring the negative down. Derivative of sine is cosine. Now, it wasn't sine of t. If it was, I'd write cosine t. Be done. It was sine of 2t. So here's the chain rule. Now I'm doing chain rule with this function. The derivative of sine was cosine. That was the outside. I keep the inside, so I'm going back here. I've done another one of these. I keep the inside 2t. And then I multiply by the derivative of 2t, which is 2. That's pretty much it. I mean, I could go only thing I could really do to simplify this one is put like the 2, out front of all of this. But other than that, this is one function times this is another. So really, I think I'm going to leave it like that, but the only thing I could do is put the 2 right there, if wanted. So again, derivative of tangent, secant squared, do not write of t, because it wasn't tangent of t. Secant squared of, I write my g, then I did the derivative of this one, and it was negative cosine of 2t. I need another chain rule there, and then it's 2. Another way to do this is just look on the inside in parentheses. And you're doing the derivative of that every time. The derivative of the parenthesis part here. Derivative of the parenthesis part there. I got one more with the tangent line to finish up. Any thoughts on A through C there? Kind of walking you kind of slow through these, but you'll see that some of this, there's not a lot of work, especially on that one. It's just knowing how to apply it correctly. Find the slope of the line tangent to the curve. So we're not actually doing a tangent line, just the slope. We could do the tangent line. We could plug in pi over 3, get a result. So just the slope. So what I'm going to need is the derivative, and I'll plug in pi over 3. As a reminder, sine to the 5th of x is really sine of x to the 5th. Right? We don't write it like this all the time because of simplicity. We don't always like writing with parentheses. But that's what this really means. So let's do the derivative. And I should identify that I need to do the chain rule. My outside function, chain rule, f prime of g times g prime. My outside function is a power, right? Something to the 5th. I like writing e to the 5th. So I do f prime. So the outside in red, that power is my f. So to do the derivative of that, 5 times u to the 4th. But I really just leave the u out because I don't have to replace it. I keep my g. My g was the inside here. I keep the sine x. And then I multiply by the derivative of my inside, derivative of g, which is sine. And that is cosine x. Again, hopefully you see some patterns here, right? You're like, really, every time the derivative of that goes right here. We multiply. And guys, if that right there was not just cosine of x, well then I do the derivative of that. You actually could. Derivative of x is 1. You can, but it's not needed. Okay, so that's it. Then I need to plug in pi over 3. That's my derivative right there. And there's none, I was just thinking, there's not really much to simplify. So let's just plug in pi over 3 and get our slope. 5 sine pi over 3 to the 4th times cosine pi over 3. So as I remember, sine of pi over 6 is 1/2. So sine of pi over 3 is the other one. It's radical 3 over 2. Cosine pi over 3, though, that's the one that is 1/2. So I just filled those in, and then I'm just going to simplify. At this point, you could really plug it in your calculator if needed. I'm just going to work it out by hand. So square root of 3 to the 4th, square root of 3 times square root of 3 is not radical 9, which is 3. And if we did it twice more, we get another 3, and so that would be 9. 2 to the 4th, 2, 4, 8, 16. And usually my final step, I'm multiplying the numerators. 5 times 9 times 1 is 45. And 1 times 16 times 2 is 32. And I think as a fraction, that's the simplest. Okay, so real quick, I want to remind you, if you, I like this as a kind of shorter method, but again, if you see it better, you can always call u the inside of my function here, sine, and do y prime times u prime. Y prime would be 5u to the fourth, u prime would be cosine x. The derivative is you multiply them, and then you change, it's up here, you change u back to sine x. So I don't hit that method as hard, but you really can do that method as well. Okay, well that's chain rule. I think it'd be good for you to try a lot of it now, just so you get some